In this video, we will be discussing stream erosion and river systems. Surface water initially moves downslope in a thin film called sheet flow. An area of high ground that separates two adjacent river valleys is called an interfluve. The interfluves direct sheet flow into small-scale downhill grooves called rills. These can develop into deeper gullies and then into a stream in the valley. Every stream has a drainage basin or watershed. These collect water and sediment from many tributaries. Drainage basins may range in size from tiny to huge. All streams start small in the uppermost portion of their drainage basins. We call this the headwaters. Drainage divides form on higher land separating drainage basins. In the slide, we see a portion of a drainage basin. From this point, the stream will continue downslope to a confluence with another stream or until it empties into the ocean or another water body. This slide shows continental divides. In the United States and Canada, mountain ranges separate the major drainage basins and send flows to either the Pacific, the Gulf of Mexico, the Atlantic, Hudson Bay, or the Arctic Ocean. On every continent, these divides provide a spatial framework for water management planners who must balance the competing demands of urban, agricultural, and industrial water uses. A drainage pattern is the arrangement of stream channels in an area. Patterns are distinctive and are determined by a combination of topography, variable rock resistance, climate, hydrology, and the structural controls imposed by the underlying rocks. Dendritic drainage patterns are the most common. Dendritic drainage patterns develop on a land surface where rocks are of uniform resistance to erosion. The trellis drainage pattern often develops in dipping or folded topography that varies in resistance to erosion. Parallel structures of more resistant rocks direct the main streams, while smaller tributary streams of less resistant rocks join the main channels. A radial drainage pattern results when streams flow off a central peak or dome. Parallel drainage is associated with steep slope and high velocity streams found on steep mountains. A rectangular pattern is formed by a faulted and joined landscape, which directs stream courses in patterns of right angle turns. Annual patterns are produced by structural domes or basins with concentric patterns of rock strata guiding stream courses. And the best name, the deranged pattern. In this pattern, there's no clear evidence of any distinct geometry in the drainage, and there's no true stream valley patterns. Every stream has a degree of inclination or gradient. This is the rate of decline from its headwaters, where the stream originates, to its mouth, where it ends. Because streams rarely maintain a straight path for very long, determining the distance between 2 points must account for the many twists and turns. Characteristically, the longitudinal profile, or the side view, of a stream has a steeper slope and V-shaped channel in the headwaters. Moving downstream, the gradient becomes more gradual, and the channel shape widens. Streams adjust their gradient and other channel characteristics, such as width, depth, and velocity, to move the sediment load. Where streams empty into a water body at their mouth, the gradient is typically gentle. Over time, the gradient adjusts to provide just the velocity required to transport the load supplied from the drainage basin. Base level is a level below which a stream cannot erode its valley. Sea level is the lowest practical level for all erosional processes in most areas. Dams create an artificial base level that also alters the downstream water temperatures, sediment load, and flood regime, among other impacts. Stream water positioned above base level represents potential energy of position. As the water flows downhill, this becomes kinetic energy of motion. The rate of this conversion from potential to kinetic energy determines the ability of a stream to do geomorphic work, and this depends in part on the volume of water. Stream discharge is the volume of water moving past a point in a given unit of time. We can see in this slide that discharge is calculated using measurements of the stream width, depth, and velocity of a given cross-section of the channel. Rivers and streams in arid and semi-arid regions may also have intermittent or ephemeral discharge. Intermittent streams flow for several weeks or months each year and may have some groundwater inputs. Ephemeral streams flow only after precipitation and are not connected to the groundwater systems. Some river systems that begin in moist regions flow downstream into arid landscapes where high potential evapotranspiration and withdrawals for agriculture and settlements may reduce the discharge. This type of stream is called an exotic stream. The Colorado River in the United States is one example of an exotic stream, which originates in the Rocky Mountain headwaters, then flows across the dry Southwest. The amount of material carried by a stream depends on topographic relief, the type of rock and soil, climate, vegetation, and human activity in a drainage basin. Bed load refers to the coarse material that is moved downstream by traction or saltation. In traction, the current drags the materials along the stream bed. When materials move downstream by saltation, the particles bounce along in short hops because they're too large to be rolled or picked up to remain in suspension. Most bed load is moved downstream during floods. During a flood, a river may carry an enormous sediment load as traction and saltation move the larger bed load downstream. When a stream's capacity to carry sediment has been exceeded, deposition of sediment begins. Deposition in a braided channel, like we see in this slide, occurs when reduced discharge lowers a stream's transporting ability. Braided channels can also occur when a landslide occurs upstream. When the channel slope is gradual, streams meander through the landscape. Meandering streams migrate across their valley bottoms in a snake-like pattern. Flow characteristics of a meandering stream are best seen in a cross-sectional view, like we see in this slide. The greatest velocities are near the surface at the center of the channel. Velocities decrease closer to the sides and the bottom of the channel because of frictional drag on the water flow. The portion of the stream flowing at maximum velocity moves diagonally across the stream from bend to bend in a meandering stream. The outer portion of each meander receives the fastest water velocity and therefore the greatest amount of erosion. The outer curve can be the site of a steep undercut bank or cut bank. In contrast, the inner side of a meander experiences the slowest water velocity and thus receives deposition, forming a point bar deposit. As meanders develop, these scour and fill processes gradually rework the stream banks, leaving residual deposits from prior channels. A looping meander often becomes isolated from the rest of a river as erosion and deposition configure a new channel through the narrow end of the meander. This results in an oxbow lake, which will gradually fill with organic debris or may become part of the river when it floods. In this process, we see step 1 in this slide where a neck forms where a lengthening meander loops back on itself. Then over time, the neck narrows as erosion undercuts the bank. Eventually, the stream erodes through the neck, forming a cutoff. And finally, an oxbow lake forms as sediment fills the area between the new stream and its older meander. Stream nick points occur where the longitudinal profile of a stream experiences an abrupt change in gradient, such as at a waterfall or an area of rapids. Nick points can result when a stream flows across a zone of hard, resistant rock or various tectonic uplift episodes, such as along a fault line. Over time, erosion by the stream eliminates the nick point and restores the stream's dynamic equilibrium. Waterfalls are actually large stream nick points. The free-falling water moves at high velocity under the acceleration of gravity, causing increased abrasion and hydraulic action in the channel below. This action undercuts the waterfall. Eventually, the excavation causes the rock ledge at the lip of the fall to collapse, shifting the waterfall a bit farther upstream. The height of a waterfall is gradually reduced as debris accumulates at its base. Many stream channels are flat, low-lying areas called floodplains. Floodplains are formed by erosion, but their surface reflects centuries of recurring flooding and deposition of sediment. When the flood water recedes, it leaves behind new deposits that cover the underlying rock with alluvium. Over time, the landscape near a meandering river develops meander scars made of residual deposits from abandoned channels. Meander scars may include traces of meander bends, oxbow lakes, natural levees, point bars, and undercut banks. Wetlands often form in a poorly drained, fine sediment deposited area when the river floods surrounding areas. The level or nearly level depositional plain that forms at the mouth of a river is a delta. Deltas occur where the river's velocity rapidly decelerates as it enters a larger standing body of water, and the sediment load is deposited. The deposits are sorted, with coarse sand and gravel dropping out first, closest to the river's mouth. Finer clays are carried farther and form the extreme end of the deposit, which may be underwater. A flood is high water that overflows the natural bank along any portion of a stream. Throughout history, civilizations have settled floodplains and deltas, especially since the agricultural revolution 10,000 years ago, when the fertility of floodplain soils was discovered. Early villages were usually built away from the area of flooding, because the floodplain was dedicated exclusively to farming. However, as commerce grew, competition for sites near rivers increased because these locations were important for transportation. Port and dock facilities were built, as were river bridges. Because water is a basic industrial raw material used for cooling and for diluting and removing wastes, waterside industrial sites became desirable. These competing human activities on vulnerable, flood-prone lands place lives and property at risk during floods. Floods are rated statistically for the probability that a flood will occur sometime during a given time interval based on historical data. For example, a 10-year flood has a 10% likelihood of occurring in any 1 year and is likely to occur about 10 times each century, which indicates a moderate threat. A 50-year or 100-year flood is of greater and often catastrophic consequences, but it is less likely to occur in a given year. That's all for this video. Thanks for watching, and I'll see you in the next one.